derivatives now let f of z be a function whose domain of definition is the neighborhood of z naught. The derivative of f of z at z naught is defined as f prime z naught limit z tends to z naught fz minus f of z naught divided by z minus z naught, provided the limit exists. So what we are seeing over here, we have a function and its value at that point, at certain point z naught. Function and its value, we take the difference of these two, and any point in the neighborhood of z naught, take the difference, then we take the ratio of these two values, then we take the limit z tends to z naught. If this limit exists, we say that this is the derivative of the function this, which is denoted by prime z naught. The strong condition on this is the existence of the limits. If the limit does not exist, this derivative does not exist. Okay. And the same definition in the real variables. We have f prime x naught limit x tends to x naught f of x minus f of x naught or x minus x naught. The function f of z is said to be differentiable if its derivative exists. If this derivative, this exists, then this function is said to be differentiable function. If we write delta z as z minus z naught, if we represent this z minus z naught to be delta z, then z is equal to z naught plus delta z. From this equation, you can take this on the other side, then z is equal to z naught plus delta z. Delta z is nothing but it's the change in z. Okay. Thus, another way of writing this equation of the derivative, we have a limit delta z tends to 0, f of z naught plus delta z minus f of z naught over delta z. When z tends to z naught, this tends to z naught, that means delta z tends to 0. So delta z tends to 0, f is replaced with z naught plus delta z, and this is divided by delta z. So this is another way of writing the same definition over here. You can either write this or you can write this. Now if we write this delta w as z plus delta z minus f of z, that is, we are now considering any point instead of a particular point z naught. If we consider any point in the plane, that is z and plus delta z, this is, so z naught is replaced by z. So if this change is represented by this delta w, this is the change in the two values, difference of the two values, value of the function at z plus delta z and value of the function at z. So if we have this difference is denoted by delta z, then f prime z is equal to limit delta z tends to 0. We have change in w over change in z, and this change ratio of two changes together with this limit is dw by dz. This is just definition method. So we have if w is f of z, then dw by dz is nothing but it's a derivative. How we find the derivative? If f of z is taken to be z square, then for any point z, this limit delta z tends to 0, this change in w over change in z, that can be written as limit delta z tends to 0, and then we have z plus delta z whole square minus z square divided by delta z. This is the value of the function. Further, it is limit delta z tends to 0. We have z square plus 2z delta z plus delta z square minus z square over delta z. So it is cancelled by this one. Limit delta z tends to 0. We have delta z into 2z plus delta z over delta z. So it is limit delta z tends to 0, 2z plus delta z, so that it is 2z plus 0, or it is 2z. So we have the same rule of definition as in real variable. We just take the power as the coefficient, and 1 is less than the power. Now consider another example. F of z is equal to z mod square. if we have instead of z square mod square. So that f of z plus delta z is z plus delta z mod square. Just for replacing z with z plus delta z. This delta w is f of z plus delta z minus f of z. So it is z plus delta z mod square minus z mod square. Sorry? Now we cannot take common over here. We are using this basic definition over here. Mod square can be written as z time its conjugate minus z time its conjugate. So that another definition of conjugate, it is z conjugate plus delta z conjugate minus z into z conjugate. This conjugate of the sum is sum of the conjugates. We can multiply this z into z conjugate plus z into delta z conjugate plus z conjugate into delta z and then plus delta z into delta z conjugate minus z into z conjugate. So we can cancel these two terms. The left one is